I will be sharing to you about evaluating functions. How do we evaluate a function? You can see there the definition of evaluating a function on your screen. But for easier understanding, to evaluate a function means to replace or substitute a given value from the function's domain to the variable in the function. In this case, usually we use the letter x. We often associate parentheses with multiplication. However, in the function notation, remember that f of x means the value of f at x. It does not mean f times x. Letters other than f, such as G and H, or the capital letters G and H, or small letters G and H, can also be used. F is the name of the function, and f of x is the value of the function at x. Let us have some example for you to understand it more. So we have here the given function 2x plus 5 to be evaluated at x equals 6. Now we need to replace all the x's with 6 since 6 is the given. Now, proceed. 2 times 6 is 12, added to 5. Therefore, the value of the function 2x plus 5 at x equals 6 is 17. Let's have another example. The function is 2x squared minus x plus 3 to be evaluated at x equals negative 3. So we will just follow the same process. All x's will be substituted with negative 3, and these are the ones in yellow. Now follow the PEMDAS rule. The square of negative 3 is positive 9. The negative of negative 3 is positive 3, then copy plus 3. So 2 times 9 is 18, then copy plus 3, or you may just add it directly. Now the final answer is 24. Easy, right? Another function, we have m of x equals 12 minus 4x to be evaluated at x equals a plus b. Now this time, the given value is not a number, but letters. Are we still going to follow the same process? Of course. So all x's will be substituted with a plus b. Now, in this line, we substituted x's with a plus b, and then proceed with the operation 12 minus, or negative 4 times positive a is negative 4a. Negative 4 times positive b is negative 4b. Basically, we distribute negative 4 to each term. Now, if there are no similar terms, that's the final answer. Or you may just rearrange it. Negative 4a minus 4b plus 12. So this is the value of the function at x equals a plus b. Let's have another given function. G equals x squared plus 3x. We evaluate the function at at x equals x minus 2. So the same process, all the x's will be substituted with x minus 2, as you can see. Now, you may wonder how to find the square of quantity x minus 2. So, just a short recall on special products, particularly on the square of a binomial. The general rule there is this. First is the square of the first term plus twice the product of the first and the second term plus the square of the second term. So applying this general rule, we have the square of quantity x minus 2, x squared minus 4x plus 4. You can see the solution in this particular part. So let's go back to our function. The square of quantity x minus 2 is x squared minus 4x plus 4. And then we distribute 3 to each term. So 3 times x is 3x. 3 times negative 2 is negative 6. In this part, we can see similar terms like negative 4x and 3x, and then the constant terms 4 and negative 6. So we need to combine them or rearrange them. We have x squared minus 4x plus 3x plus 4 minus 6. And then x squared, just copy x squared since there are no similar terms. And then negative 4x plus 3x is negative x. And then 4 or positive 4 minus 6 is equal to negative 2. Therefore, the value of the function g at x minus 2 is equal to x squared minus x minus 2. So now I'll be giving you these practice exercises. Try to comment or post your answers and let's check whether you get the right one. That's all for now. Bye.